Welcome to BYJU'S Exam Prep. So guys, this is the next session for your 2020 series in which we will discuss the problem which is related to the RCC part. And you know that guys, in this particular subject, you may get a question which is a basically numerical type as well as the theoretical type questions for your GATE examination. So I have put it all the variety of questions over here, whether it is your theoretical part or numerical part, MSQ question, MCQ question or NAT type question. So in this session, you will get all the variety of problem. Okay. And the second thing is that guys, this subject is very scoring also. And if you are able to know the concept, if you know the things properly, then you are able to solve the problem very well. Okay. So let's start the session guys and quickly share it to other student also so that everyone can join the session and they will also watch it. Okay. So those students who are watching this video as a first time, so let me tell you about myself. My name is Krishna Yadav and I have done my masters from IIT Roorkee. So guys, this is basically the GATE Achievers series which you can join on our application. And there is one live session guys which is on 8th of November which you can join at 8 p.m. So let's start with the question number 1. Okay. Please reply in the chat box guys and let me know the correct answer for each and every problem. Okay. So this is the first question in front of you. So kindly read it very carefully guys because some questions are very tricky in this session also. And you may get trap also, right? So that is the reason you have to read it very well. So this is first question. What is the meaning of the designation M30 concrete suggested for RCC concrete work? That is the first statement guys which is in front of you. Now you need to tell me which one is the correct answer for the problem. What is the meaning of M30 grade? So you know that guys, M belongs to what? Mix. M is what? Mix. And 30 is what? That is basically characteristic strength of concrete. Wali C, Raj C. Okay, we'll check it out. You know that guys, what is characteristic strength? Right? But that characteristic strength should be defined for a cube which is basically of dimension 150 mm. 150 mm. And the compressive strength which you have to measure, that is basically after 28 days. After 28 days, right? After 28 days of curing. So whatever value of strength you are getting guys, that is basically our compressive strength. Now you know that what is characteristic strength? If you have 100 sample, so out of those 100 sample guys, if 5% of test result are lesser than this particular value, which is basically 30, and 95% test result are greater than this particular value, then this value should be known as what? Characteristic strength. So it should be measured in a cube whose means for a cube which is basically of dimension 150 mm and after 28 days. Oh, okay. So that's why guys, C is the correct answer for the problem. The mixed characteristic compressive strength of 150 mm size cube at 28 days in 30 Newton per mm square. Next question in front of you guys. Tell me the correct answer for this. Which of the following statement is true? There are basically 4 statements over here. You need to tell me which one is the correct answer. Okay. Pradvi Valli, kindly tell me the correct answer for the problem. Okay. So the first statement says, if the characteristic strength be defined as that value below which not more than 50% of test result are expected to fall. You know that guys, the same definition is to be used for your target mean strength also. That means the target mean strength is represented by Fm and this value is nothing as, this is the characteristic strength of cube below which not more than 50% of test result are expected to fall, right? So this is basically target mean strength. But as per the definition which is written in the statement 1, the characteristic strength is also defined in the same way. If it is defined in the same way, so can I say that guys, Fm and FCK should be same, right? But as per the statement number 1, the target mean strength is greater than characteristic strength. This statement is wrong. If you are defining the characteristic strength similarly to your target mean strength, then this particular statement will be wrong. Similarly guys, the second statement is also wrong. The target mean strength is less than the characteristic strength. We are using the same definition for characteristic strength again, but this relation is wrong guys. Okay. If target mean strength and characteristic strength are same, then the value of standard deviation is 0. We know that guys, there is one relation which we can write Fm is equal to Fck plus 1.64 into sigma. Now, if these two values are same, then it means the standard deviation should be equal to how much? It should be 0. So this statement can be correct. Can be correct. What about this one? We know that, guys, this relation is wrong. It should be positive. Next question in front of you, and it is a tricky one. A reinforced concrete beam is subjected to the following bending moments, like due to live load 30 kilonewton meter, seismic load 10 kilonewton meter. Now, what is the value of design bending moment as per the LSM method? Tell me, guys. What is the bending moment as per the LSM method for the problem? Tell me, guys. I want answer from your side first. What should be the value of design bending moment for this particular problem? Tell me, guys. I'm reading your comment. It is a little bit tricky question. Quickly tell me, guys, you know that what is live load, what is seismic load, and how much factor of safety you have to take, right? Do you know that? Tell me, guys, quickly, you have to give the answer. B, that means 60. As per Pradhvi Raj, it is B, that means 60 kilonewton meter. Okay. Let me tell you one thing, guys, none of the correct answer is there. That means D is the correct answer for the problem. Now, why D is correct? Why D is correct? Let me tell you one thing, guys. Whenever you are trying to calculate the design bending moment or design load in the LSM method, there is some minimum criteria. You need to consider at least dead load should be there in your calculation. If dead load is not there, guys, so such type of combination of load is not mentioned as per the IS code, right? If you have only live load and seismic load, you are not able to estimate the design bending moment value. You need one more value which can be dead load, guys. So, guys, there can be some combination like this, dead load plus live load, or either we will have dead load plus seismic load, right? Or we can have dead load plus live load plus seismic load. So in this particular case, you are able to see the dead load is the minimum requirement to find out the design value of the design value of bending moment or design load value. That's why, guys, none of the combination can be correct, and that's why D is the correct answer for the problem, right? And it is a tricky one, right? Next question in front of you, kindly read it very well. Okay, so a rectangular beam whose width is 300 mm and having an overall depth of 600 mm, correct? Now the concrete grade is M20 and the grade of steel which we are using is Fe415. Okay, sir. The tensile reinforcement is provided by 5 20 mm dia bar and 2-legged 10 mm dia as a shear reinforcement. And the clear cover is also mentioned, it is 25 mm. We just need to calculate what is the value of effective cover in mm. Let me show you the figure first. So, guys, this is the cross section which is mentioned in the problem, and this dimension is basically 300 mm, and the overall depth is also given to us, which is basically 600 mm, correct? Now we need to use M20 and Fe415, so there is no requirement of such type of grade, you know that. Swapnil A, okay, 45 mm, very nice. Let's see. The dia of tension reinforcement is given to us. This is tension, this is tension, this is tension, this is tension, and this is also tension reinforcement. As well as, guys, we will have some shear reinforcement in this particular case, which is to be like this. Clear? Now what we need to calculate, we need to find out the effective cover for the beam. What is the value of effective cover? Effective cover, very easy to calculate. So effective cover is equal to what? Effective cover is equal to what? Clear cover. So what is the value of clear cover? This value is already mentioned, 25 mm. So we need to write 25 plus the dia of shear reinforcement. Okay. So the dia of shear reinforcement is how much? It is 10 plus half of the dia of tension reinforcement. That is basically 20 divided by 2. So if you calculate it, you will get 45 mm as a effective cover. That's why A is the correct answer. Swapnil, very good evening. A is the correct answer. Understood? Listen carefully, guys. Whenever in the question they have mentioned the shear reinforcement, you have to consider it while calculating the effective cover. Be careful, right? Be careful. If it is mentioned in the problem, you have shear reinforcement in your beam, then kindly consider that particular value also in the calculation of effective cover. If it is not mentioned in the problem, then you can ignore it. Otherwise, you have to consider it. Okay. Next question in front of you, guys. Again, it is a tricky one. Again, it is a tricky one. Okay. I'm giving the hint. Okay. It is a tricky one. Which one of the following is the correct as per the LSM method, as per the limit state collapse? Which one of the following is the correct option? Or you can say that which one is the correct answer? Kindly read the question very carefully, guys. Okay. And tell me the correct answer for this problem. Swapnil, good evening. Please write your answer in the chat box. I hope all of you know the basic concept of LSM method, right? Fifth A, 1, 2, 3. Wali B, okay, 2 and 3. Okay, what about rest of the students? What about rest of the student? Okay, Wali. Okay, Pradvi. Tell me, guys, it is a very simple question. You have solved a lot of time such type of problem like under reinforced section, balance section, over reinforced section, etc. But why you are not giving the answer? C only. Okay, 2 only. Okay, let's understand. Guys, the correct answer is D. The correct answer is D. But let me explain. You know that, guys, what are under reinforced section? What is, let me write here over here, like this. Let us suppose this is your axial limiting value, which is known as limiting depth of neutral axis. You know that, guys, there are 3 conditions which we need to understand. One is if XU is less than XU limiting. So such type of case is what? Under reinforced case. Yes, it is correct. As well as the area of AST which you have to provide in case of under reinforced section, that is less than AST limiting value. Correct? So this is also correct. As well as we know that, guys, if the area of steel is lesser and the depth is also lesser, so in that particular case, the moment of resistance will be less than the moment of resistance of limiting section. So can I say that, guys, the first option is correct? This one is correct. Okay. Now let me explain the second part. XU is equal to XU limiting. Yes, definitely. AST is equal to AST limiting. Yes, definitely, for the limiting section or balance section. And MOR is equal to MOR limiting also. Yes, it is also correct. But if you talk about, guys, third option, you have to think about it. The value of XU is greater than XU limiting. Yes, it is correct. The area of steel which we have provided is greater than AST limiting value. It is also correct. But this statement is wrong. The moment of resistance by the over reinforced section is always equal to the limiting section only. So MOR of limiting is equal to MOR for over reinforced section. Do you remember this? The moment of resistance for over reinforced section is always equal to MOR of limiting section, right? It is not possible to have greater moment of resistance as compared to the limiting section, right? That's why, guys, only 2 option is correct, 1 and 2, and that's why D is the correct answer for the problem. Crystal clear? Next question in front of you, guys. Next question in front of you. Which of the following statements are correct? Which of the following statement are correct? Tell me, guys. Which of the following statements are correct? 1 mark question. Which of the following statement are correct? Kindly read the question very carefully, okay? Three. Okay, that means C. Okay, Vali. Now listen, do you know that what is bent up bar? Generally, we are using bent up bar to resist the shear force, right? And what is bent up bar? Some of the main bar you have to bend at some location so that they can take care of the shear force. Now at the same time, guys, this particular portion which is extended on this particular area will try to resist the negative bending moment. It will try to resist negative bending moment. How it is possible? Let me show you that. Let us suppose this is your fixed beam, right? Let us suppose this is your fixed beam. Now you can see here, guys, if you put any kind of UDL on the entire span, the BMD of this particular structure will be like this. So this is positive bending moment, this is negative, this is negative. So you know that, guys, if it is negative bending moment, then definitely the tension reinforcement should be required near to the top fiber, That's why whatever bent up bar you are using at the support, it will try to resist some positive bending moment in this particular zone, right? So that's why, guys, this statement is correct or wrong? Tell me, it is wrong or it is correct? It is wrong, right? It should be wrong. The bent up bar at the support resists the shear force. Yes, definitely it is correct. The bending of the bar near the support is generally at an angle of 45 degree. Yes, definitely this angle should be is 45 degree. So only 2 and 3 are correct. That's why D is the correct answer. D is the correct answer for the problem. Clear? Next question in front of you, guys. Kindly see the graph and then put your answer. Okay. I'm hiding myself so that you can see the graph easily. I'm hiding myself for temporary purpose, for temporary reason, right? So kindly see the question, guys, and kindly see the graph properly and let me know the correct answer. The design stress strain curve of concrete is shown in the figure below. Identify the two missing values P and Q and select the correct option. You need to tell me what is this value P and what is this value Q. D. Very nice. You already know that, guys, we need to consider 0.45 FCK over here and the strain value is 0.0035. So the value of Q is equal to 0.0035 and the value of P is equal to 0.446 FCK. That's why D is the correct answer for the problem. Very nice. Very nice, guys. Next question in front of you. Next question in front of you. According to IS 456-2000, which of the following criteria is not valid for the column? You need to tell me, guys, out of these statement, which particular statement is wrong for your column? That is the question. There are 4 statements. Tell me which one is the wrong answer. You know that, guys, the minimum dia in case of column which we have to use in place of longitudinal bar should be equal to 12 mm. So the first statement is correct, right? D is wrong, sir. Okay. First statement is correct. And the maximum compressive strain in the concrete in axial compression is 0.002. This is also correct. This is also correct. To find out the load carrying capacity of a column, grade of concrete, grade of steel, cross section area of column, dia of longitudinal reinforcement is also required. These statements are correct. But what about the last statement? For a circular column with lateral tie, load carrying capacity is increased by 5%. Now let me tell you, guys, whenever you have a circular column, it is not mandatory to increase the load carrying capacity by 5%. In such scenario, what you need to do, guys, you need to provide the helical reinforcement. So whenever we are trying to provide the helical reinforcement, then only you have to increase the load carrying capacity by the column. Otherwise, if you have a lateral ties only, which is a circular tie, in such case, the same formula should be applicable, which you have to use to calculate the load carrying capacity by the column, right? In that case, you don't have to increase the value by 5%. That's why, guys, D is the correct answer for the problem, right? In such case, we need to increase the value by 5%. But in this particular case, guys, we don't have to do. We don't have to do it. Let me show you that particular figure also. Let us suppose again this is a circular column and these are circular ties. So in such case, you don't have to increase the load carrying capacity by the column by 5%. Okay. Next question, guys. So only D is the correct answer for the question. Next question in front of you. An unrestrained reinforced concrete slab of effective dimension 4.5 into 6 meter is simply supported on all 4 walls. It has to carry a characteristic live load of 10 kN per meter square in addition to the dead load. Assume M25 and Fe415. The thickness of slab is 20 mm and the floor finishing is 1 kN per meter square. Then what should be the design load as per the LSM method? That is the problem. What is the value of design load as per the LSM method? So you know that, guys, how to calculate the design load. First, they have given the live load, which is 10. Now let's calculate the value of load which is due to the dead load also. So we need to consider a small area 1 cross 1, which is our square area, multiply by unit weight of concrete 25 and the thickness of slab is 0.2 meter. Then plus floor finishing value is 1 and bracket we need to multiply it by 1.5, right? So that we can calculate it in terms of design value. Okay, kindly do it. So this value is coming around 24. This value is coming around 24 kilonewton per meter square. And that's why, guys, B is the correct answer for the problem. B is the correct answer for the problem. Clear? B is the correct answer for the problem. Kindly tell me, guys, it is clear to all of you? Crystal clear? Okay, very nice. Now let's move to the next question, guys, which is related to the deflection criteria as per your limit state of serviceability. Now what is given in the problem? A simply supported slab whose span is equal to 12 meter. And as per limit state of serviceability, we need to calculate the minimum effective depth which is required so that it can be safe in the deflection criteria, right? You need to calculate the value of small d so that it will be safe in the deflection condition. So do you remember that particular criteria which is mentioned by IS code? Span by d value should be less than or equal to a value. But this formula is valid only when the span of the beam is less than or equal to 10 meter. Now in our case, we know that, guys, the span is greater than 10 meter. It is 12 meter. So you need to modify the value of A. So what should be our formula? New formula. Span by D value is less than or equal to A value multiply by 10 by span value. And span should be in meter. So let's calculate it, guys. This span is 12 meter divided by D is equal less than or equal to. For simply supported condition, the value of A is how much? It is 20. Multiply by 10 divided by again 12. So let's calculate the value of D. How much we are getting? A. Okay. So this value is coming around 0.72 meter. Or you can write here, guys, 720 mm. So that's why A is the correct answer for the problem. Okay. Next question in front of you, guys. Next question in front of you. Determine the, very nice Vali, very nice Prithvi. Determine the minimum and the maximum longitudinal reinforcement for a square column whose size is 300 cross 300 and having a clear cover of 25 mm, right? You need to just estimate what is the value of minimum and maximum longitudinal reinforcement in case of column. AST minimum and AST max. AST minimum is equal to how much? AST minimum is equal to how much? You know that, guys, the AST minimum value is 0.8% of cross section area, which is 300 across 300. Okay, so let's calculate it. 0.8 divided by 100 multiply by 300 across 300. If you calculate it, it is coming around 720 mm square. Now next is AST max. So AST max is equal to how much? It should be 6%. 6% of cross section area. So 6 divided by 100 multiply by 300 multiply by 300. So how much it is? 5400 mm square. And that's why, guys, D is the correct answer for the problem. Very nice, Raj. Next question, guys, which is related to the design for shear part. Okay, very nice, Swapnil. This is related to the design for shear part. So I'm just hiding myself so that you can read the table properly. Okay. Now kindly check out the question, guys. What is given in the problem? The rectangular beam of width 200 mm and having effective depth of 300 mm. As per the limit state method, if the percentage tension reinforcement is 2%, then the critical shear capacity of the beam is equal to how much? Critical shear capacity of the beam is equal to how much? That means you need to calculate the value of VC, which is related to the tau C. So kindly check out, guys, for PT is equal to 2%. What is this? This is basically PT. For PT is equal to 2%, then what is the value of tau C? It is 0.79. So we can write here tau C is equal to how much? 0.79 Newton per mm square. So let's calculate the value of VC. VC is equal to how much? Tau C into B into D. So tau C is equal to how much? It is 0.79. B is equal to how much? B is equal to 200 and small d is equal to 300. And let's multiply it by 10 raised to power minus 3 so that we will get our answer in terms of kilonewton. So guys, this value is coming around 47.4 kilonewton, and that's why B is the correct answer for the problem. Very nice. B is the correct answer for the problem. Now the next question is also a tricky one, guys. This problem is a little bit tricky one. Okay. Kindly read the question very carefully. Okay. Kindly read the question very carefully. Now listen it properly and kindly solve the question very well. Okay. So a rectangular column size 400 cross 450 mm is reinforced with 20 mm dia, and these bar are equally divided in opposite side. That means if you are providing 5 bar over here, then the 5 bar should be in front of that also. Okay. It should be equally divided, not unequally, equally divided. The grade of concrete is M20, steel is Fe415. The computed ultimate load carrying capacity by the column is 2190. Then the number of 20 mm dia bar required is equal to how much? Very simple thing. Let's solve the problem. You know that, guys, how to calculate the value of PU. PU is equal to how much? It is basically 0.4 FCK into AC plus 0.67 into Fy into AC. This should be the formula. What is the value of PU? It is 2190. So 2190 multiplied by 10 raised to power 3. And it is equal to 0.45 FCK. FCK is 20. AC. AC is net area of concrete. after deducting the area of steel, you need to write the area of concrete. So the cross section which is mentioned over here is 400 cross 450 minus area of steel. Let us consider ASC. Okay. Plus 0.67 FY. FY is 415. Then multiply by ASC again. Now let's calculate what is the value of ASC. 219 0000 0.45 into 20 into 400 into 450. So this value is 1620000 minus. This value is 9 ASC plus 278.05 ASC. Now let's calculate the value of ASC, guys. How much it is? ASC is equal to how much? So 2190000 minus 1620000 divided by 278.05 minus 9. Kindly solve it. You will get the area. So this value is 2118.565 mm square, right? So we have to write n number of bars whose dia is 20 mm is equal to 2118.565. Now let's calculate the number of bar which is required. How many bars are required? How many bars are required? Tell me, guys. .74. .74. Very nice. 6.74. Wait a second, guys. Wait a second. Just a second. Just a second. I think we have done a smaller calculation mistake. This value should be 0.4, right? So we need to write it accordingly. So 0.4 into 20 into 400 into 450. So this value is actually different. It is 1440000. Sorry for this one, right? And what about this one? 0.4 into 20. So this value is not 9. It should be 8. I think that the rest of the calculation is correct. Let's correct it. And this should be 8. Okay. Let's calculate the area. Pradvi, kindly calculate the area once again. So guys, this value is coming around 2687.7. Okay. Now put this value 2687.7 and calculate the value of number of bars. Now we are getting a value of 8.55. 8.55. 8.55. Now tell me, guys, if it is 8.55, then how many number of bar you have to provide and what will be your answer? We can round off it as 9. Okay. Now check it, guys, which particular answer you have to put. There are 4 options: 6, 11, 10 and 9. Tell me which is the correct answer. 10 bars. Okay. Pradhi says, sir, 10 bar. Yes, definitely it should be 10 bar. We are not able to provide it 9. We are not able to provide as 9. Why? Because I need to provide the reinforcement equally on both the sides. That is the reason, guys, the answer should be 10. It should not be 9. Clear? Very nice. Let's move to the next question. A very simple question, guys. directly answer you can put over here. Which of the following are correct for the pre-stressed concrete beam? Which of the following are correct for pre-stressed concrete beam? Out of these three statements, which of the following statements are correct? See, all statements are correct. Very nice. All statements are correct. The construction required additional special equipments like jack and anchorage. Yes, definitely. It required highly skilled worker under skilled supervision. Yes, definitely. The construction cost is little bit higher than the RCC. Yes, it is so. Why? Because we are using a higher grade of concrete over here, right? And the structure we are constructing over here, guys, it is basically the large span structure. That's why the cost will be little bit higher also. So C is the correct answer for the problem. Next question in front of you. What is the maximum possible eccentricity in a pre-stressed concrete beam of a circular cross section? The dia of section is D and tension is not allowed anywhere and anytime in the cross section. Neglect the dead load or self-weight and tell me what should be the minimum eccentricity in this case so that there should not be any tension in the beam. 15. Question number 15. Wali A, D by 8. Yes, definitely D by 8 is the correct answer. D by 8 is the correct answer. But I will explain, guys, how it comes actually. Let me explain it, guys. Let us suppose this is a circular pre-stressed concrete beam. And let us consider this is our longitudinal or neutral axis. And let us suppose this is the level where we are trying to provide the cables. This is the location where you have provided the cable. Let us consider the eccentricity for this is E and the pre-stressing force is P. Correct? Now tell me, guys, if you calculate the stress at the top fiber, right, or if you want to calculate the stresses over here, so there are two types of stress which will come. One is direct compression and second is bending compression and bending tension. At the top you may have bending tension, so that's why, guys, the diagram should be like this, and at the bottom it should be bending compression. So this value is plus, this value is plus, this value is negative, this value is plus, this value is P by A and this is PEY by I. But we know that, guys, on the top area we are having a negative value. So if you want to make zero stress at the top, or there should not be any kind of tension, then what you need to do? You need to add these two values, P by A minus PEY by I, right? According to algebraic sum, you have to do it and make it zero, right? Make it zero. So P by A minus PEY by I should be equal to 0. So if you solve it, what we will getting over here, guys, let's understand. You need to cancel P to P. So the value of E is equal to how much? It is I by AY. So what is the value of moment of inertia for a circular cross section? It is pi d square, pi d raised to power 4 divided by 64. What is the area? Pi d square by 4. And what is the value of y? It should be d by 2. Now let's cancel pi to pi. Let's cancel these two values also and it will become 8. And if you cancel this one, d square d, so it will become d by 8. Right? So that's why, guys, A is the correct answer for the problem. Clear? Next question. Numerical answer type. Next question. Numerical answer type, which is based upon loss of pre-stress. It is based upon loss of pre-stress. There is a simply supported pre-stressed concrete beam whose span is 20 meter and the initial stress is 1000 megapascal. So what is given over here, guys? L is equal to 20 meter and the initial pre-stress, which is P naught, that is equal to 1000 megapascal. Okay. Now the slip will occur in the jack during the tensioning process and it is 2 mm basically, right? That means delta is equal to how much? It is 2 mm. Now ES is equal to 200 gigapascal. Then how much percentage of pre-stress is dash remaining after considering the loss? So first you need to calculate the amount of loss of pre-stress. So that is basically del by L multiplied by what? ES. So del is equal to how much? 2. L is equal to how much? 20 meter. So 20 into 10 raised to power 3 multiplied by ES, it is 200 gigapascal. 200 into 10 raised to power 3. Let's calculate what is the loss of pre-stress which is occurring in this case. So guys, this value is coming around 20 megapascal. Correct? Now we just need to estimate how much percentage of pre-stress is remaining. So can I write here, guys, pre-stress remaining, percentage of pre-stress remaining, initial value is how much? 1000. Loss is how much? 20. So this will be the remaining part, right? What was the original value? 1000 and multiplied by 100. You will get the answer. %. Very well. Very well, Raj. 98% is the correct answer. 98% is the correct answer. 16 ka. Yes, 98%. Next question, guys. This question is basically MSQ type question and is very well designed so that you can understand all the concept of shear designing problem. Okay. So first you need to read the statement properly. Then read the option also very carefully, guys, because there are some trick or some change in the statement in the option also, right? So kindly read the question first. A rectangular beam whose width is 350 mm and the overall depth is equal to 500 mm and it is provided with 20 mm dia. Okay, and Fe415 bar we have to use on the tension side whose clear cover is 25 mm. Okay, this is our cross section in which width of the beam is given to us 350 mm and the overall depth is equal to 500 mm. The dia which we are using over here, guys, which is basically 20 mm. Okay, right now we don't know how many number of bars are there, just write it down, 20 mm. Okay, and the clear cover which you have to provide over here is 25 mm. The beam is made with concrete having tau c is equal to 3.1 Newton per mm square. The value of tau c max is given to us and the reinforcement provided and the grade of concrete which we are using over here, it may be assumed that tau c is equal to 0.8. Okay, so there are two value which is given to us. Tau c max is already mentioned. This value is 3.1 and tau c is equal to how much? Tau c is equal to 0.8. Okay, the design shear in the beam, is 400 kilonewton. Consider the provision of IS 456-2000. Which of the following are true? Right? So kindly read the statement, then only you can understand what you have to solve over here. The first statement says the shear reinforcement should be designed for this particular value of shear force. How we can calculate it? First we need to calculate the value of what? Tau v, right? How we can calculate tau v? We need to estimate the value of small d first. So effective depth, overall depth is how much? Overall depth is 500. minus effective cover minus dia of main reinforcement divided by 2. So how much it is? 500 minus 25 minus 10. So we are getting a value of 465 mm as a small d. Now let's calculate the value of tau v. Tau v is equal to Vu by B into D. So Vu, design shear force is given. Yes, it is 400. So 400 into 10 raised to power 3 divided by B. B is 350. Small d is equal to how much? It is 465. So kindly calculate the value of tau v. How much you are getting, guys? This value is 2.4577 Newton per mm square. Now tell me, guys, this value is less than tau c max. Kindly check it. This value is less than tau c max, but it is greater than tau c. It is less than tau c max. It is okay, but it is greater than tau c. Then we need to use the design concept. Okay. So what should be the design shear force? Let's calculate it. Tau v minus tau c multiplied by B into D. So tau v is 2.4577. Tau c is equal to 0.8 multiplied by B. B is 350 and D is equal to 465 and then multiplied by 10 raised to power minus 3. You will get the answer. So this value is coming around 269.8 kilonewton, and that is our design shear force. Clear? That is our design shear force. So which particular statement is correct? First statement is correct. Okay, but we need to check other option also, guys, because this is a MSQ type of problem. Okay, if design shear force is double, then section should be revised. Let's consider it. If we double the design shear force, that means if you change the value of Vu, make it 800, then what will happen? That you have to calculate. So let us consider, guys, if Vu is become 800 kilonewton, then in that particular case, the value of tau v is equal to how much? 800 10 raised to power 3 divided by 300 and 465. Let's calculate this value. So this value is coming around, sorry, this is 350 now. This value is coming around 4.91 Newton per mm square, right? So in this case, the tau v value is greater than tau c. So section should be revised. Section should be revised. So if design shear force is double, then section should be revised. This statement is also correct. This statement is also correct. Clear? Now let's understand the next one. In the next statement, what is written over here? If the design shear force is reduced by 4 times, then provide minimum shear reinforcement. That means I need to reduce this value of Vu by 4 times. Initially it was 400. Now we need to consider Vu is equal to 100 kilonewton. Now let's calculate the tau v value. 100 into 10 raised to power 3 divided by 350 and 465. So guys, this value is coming around 0.6144. Now can I say that tau v is less than tau c value? If it is lesser, then tell me, guys, in such case you need to design or you need to give minimum reinforcement, minimum shear reinforcement, correct? So this statement is also correct. This statement is also correct, right? This statement is also correct. Yes. Now let's read the last statement. If the depth is increased, then nominal shear stress will increase. Tell me guys, it is a basic formula. Tau V is equal to V by B into D. If you increase the value of D, then definitely tau V value will decrease. So this statement is wrong. So only A, B and C are the correct answer for the problem. Crystal clear? Crystal clear to all of you? And this is the MSQ question guys. And I think all of you are able to understand all the concept which is required for your design of shear reinforcement. Okay. Let's move to the next question guys, which is again MSQ type problem. And it is related to your development length. Let's understand it. All these questions are designed by me guys, so that you can have the complete knowledge and you are able to practice it very well. Okay. Let's read the statement. So as per IS 456-2000, for M25 and plane bar which is in tension, then the permissible bond stress is equal to tau BD and it is equal to 1.4 megapascal. Now as per the first statement, for plane bar, this value is the development length when the dia phi t is equal to what? Dia of tension reinforcement. Now you know that guys, if we want to calculate the LD value, which is development length, 0.87 Fy into phi t divided by 4 times tau BD permissible. So 0.87 Fy, we are using plane bar, that means the grade should be 250 multiplied by phi t divided by 4 times tau BD. Tau BD is equal to how much? 1.4. Now let's calculate this value. So this value is coming around 38.83 phi t, right? So the first statement is true. The first statement is true. Yes or no? First statement is true. What about second statement? If we use HYSD bar, then development length is increased by 60%. You know that guys, if you use the HYSD bar in place of plane bar, right, in place of plane bar, the value of permissible bond stress will get increased by 60%. This statement is false. This statement is false. Development length will not increase by 60%. The permissible value of tau BD will increase by 60%. Do you remember this statement? So that's why guys, this statement is wrong. It is not true, Wali. It is wrong. It is a false one. The value of tau BD should be increased by 60% in case of HYSD bar. Okay. Now let's calculate it also guys, whether it is increased by 60% or not. You are able to understand in the next statement also. If we use HYSD bar, then development length is equal to this one. Let's understand guys how we can calculate it. Now let us suppose if you are using the HYSD bar, then how we can do the calculation? 0.87 Fy. Now in this case, the value of Fy is 415. Multiply by phi t divided by 4 times tau BD permissible. Now the tau BD permissible value should be increased by 60% as per Indian Standard Code. I need to increase it by 60% and the permissible value which was earlier there 1.4. Now let's calculate this value, how much we are getting. So this value is coming around 40.29 phi t, right? 49.25 t means 40.3. So statement C is also correct. Statement C is also correct. A is correct. C is correct. B is wrong. Let's read the next statement and the last one. Means last statement basically. If we use HYSD bar, then development length is equal to this, where phi c is dia of compression reinforcement. That means if you use dia of compression reinforcement or compression reinforcement you are using, again the value of tau BD permissible will be increased by 25%. So let's calculate it, guys. LD is equal to 0.87 FY. But now we are using die of compression reinforcement divided by 4 times 1.6, 1.4 and then multiply by 1.25 also. So calculate it. How much will be the answer? So guys, we are getting a value of 32.23 die of compression reinforcement. So this is the value of LD. So again, the D statement is also correct. D is also correct. Tell me, Prithvi and Vali. A, C, D are the correct answer, but B is the wrong one. Crystal clear? Very nice. Let's move to the next question, guys. Next question in front of you, which is a numerical answer type problem. A rectangular column whose dimension is given to us and in which 6 number of bars whose dia is 20 mm we are using, and it is equally divided on the opposite side. The grade of concrete is mentioned M20 and Fe415 is used. Compute the axial force PUZ. We need to estimate the PUZ value to calculate the ratio of PU by PUZ according to LSM method. So guys, in this particular problem, you need to estimate the value of PUZ. Okay, let's do it. PUZ is equal to how much? You know that, guys, this is basically ultimate load carrying capacity by the column, and it should be 0.45 FCK into AC plus 0.75 into Fy into ASC. This should be the formula. Okay, so 0.45 FCK is how much? We are using 20 and area of concrete. So this is the cross section, 400 cross 450 minus 6 number of bars. So this will be the area, net area of concrete plus 0.75 Fy is how much? 415. And then again multiply by the area of reinforcement. Right? So kindly put the bracket and multiply it by 10 raised to the power minus 3. You will get your answer. Kindly solve it, guys, and let me know the answer, guys. How much you are getting? How much you are getting? One 1603035.4 plus. And this value is 586692.42 bracket 10 raised to the power minus 3. So we are getting a value of, hello Santu, 2189.72 kilonewton, and this will be the answer. 2189 kilonewton. Crystal clear? Now let's face the last question of the session. This is the last question of the session, guys, right? So in the pre-stressed concrete beam, a section is given to us, right, and all the dimension is in mm. If the net loss is 20% and the final pre-stressing force is 500 kilonewton. So guys, can we calculate the initial value of pre-stressing force? This is the final value, 500, and 20% is loss. 20% is loss, that means we need to divide this value by 0.8, right? So 500 divided by 0.8, we will able to calculate the initial pre-stressing force, which is 625 kilonewton. Okay. Now first statement, again guys, be careful, this is MSQ type question. We need to calculate initial extreme stress at the top fiber. So do you know that guys, what should be our formula to calculate the stresses at the top fiber? It is P by A minus PEY by I. For top fiber, this should be the formula when we are having eccentricity at this level. Clear? But we need to estimate the initial extreme stress. Okay, how we can do it? We need to put initial value of pre-stressing force, which is 625. Divide by cross section area 250, and this one is 150 and 150. That means 300 minus 625 multiplied by 10 raised to power 3 is equal to how much? It is basically 75. 75. Y is how much? 150. Now divided by moment of inertia, which is basically BD cube by 12. So B into D cube divided by 12. How much you are getting? Minus 4.167. Minus 4.167 megapascal. Kindly check it. All of you are getting the same answer or not? All of you are getting the same answer? Yes, very nice. So the first statement is correct. First statement is correct. Now let's read the next statement, guys. The final extreme stress at the bottom fiber is equal to this much. The final extreme stress at the bottom fiber. How you can calculate the final extreme stress? You need to use the final pre-stressing force, which is basically 500. Okay. Divide by area. In case of bottom, the value should be added. So PEY by I, that means P final EY by I. Let's put the final value of pre-stressing force, 500 into 10 raised to power 3 divide by area plus 500 multiplied by 10 raised to power 3 multiplied by E is equal to 75. Y is equal to how much? 150, and divide by moment of inertia. How much you are getting? Plus 16.664, very nice, plus 16.664 megapascal. So this is the correct statement. This is also correct statement. Next one, final extreme stress at the bottom fiber is 16.664. Now there are two statements which is remaining. The final stress at the top fiber is 0 when E is equal to 75 or E is equal to 50. That we have to estimate. So you know that, guys, how we can do it. Just you need to put this particular relation is equal to 0. You will get the answer. So P by A is equal to PEY by I. You can cancel these two values. So value of E is equal to how much? It is I by AY. So what is the value of I? It is BD cube by 12. So 250 into 300 cube divided by 12. Now divide by area. Area is how much? 250 into 300. And what is the value of Y? Y is nothing as it is basically 150. Let's calculate the value of E. How much you are getting? So guys, this value is coming around 50 mm. 50 mm. So can I say that this D option is correct, but C is wrong? So A, B, D are the correct statement. A, B, D are the correct statement. Now tell me, guys, how's this session? I think all of you have loved it, and all of you are able to understand all the variety of questions which we have discussed today. Yes or no? and please hit the like button if you like the session. Okay, and you will get this particular PDF guys on my Telegram channel. Okay, so all these questions has done. Now guys, if you have any doubt, any query, you can ask me. Otherwise we will close the session and we'll meet in the next one. Okay. Any doubt, Pradvi? Any doubt, Santu? Any doubt, Vali? If you have any query, any doubt, guys, you can ask me right now. There is no problem. Okay, then let's close the session. Sir, one more session on environment, please. Okay, Santu, we will plan it. We'll plan it. Okay, so let's close the session, guys, and let's meet in the next one, right? So I hope you are doing well, and keep practicing, guys, and keep solving the PYQs, and please try to solve your test series also, and etc. Right? It is very important, and right now it is very important to solve the question. Do the complete practice, right? And whatever difficulty you are facing while solving the question, if you get some new concept, kindly add it into your notes, right? It will be act as a filling method to your notes also. Okay, so that's it, guys, from my side. Let's close the session and let's meet in the next one. Thank you so much for joining the session, guys. Let's meet in the next one, guys. Okay, bye.